Hi, Dr. Vargas and TAs, how are you? This is our little group, Ding Liu, Henan Wang, and Dacheng Gao. Our topic about critical presentation is a thermodynamic correlation of gas solubilities. Our presentation contains three parts: methodology, critical testing, and critical issues.
Hi, this is Ding Liu. I'm going to give you a brief introduction and methodology of this article. Regular solution equation, as shown on the slide, is considered as a general way to obtain gas-liquid solubilities. It's worth noting that this equation is used in non-polar system and is supposed to assume no volume change. In the article, the author would like to use the regular solution equation to some gas dissolved into liquids. Let's begin with considering the gas solute in non-polar solvent. The regular solution equation cannot be used directly since it assumes no volume change. Therefore, the author regarded the dissolution process as an isothermal process in two steps. First, condense the gas to a hypothetical state having a volume close to a partial molar volume which it has as a solute in the liquid solvent. Second, dissolve this hypothetical liquid-like fluid into the solvent, and then the regular solution equation can be used in the second step. The figure 1 is plotted based on several certain gases and can be used to predict most gaseous solubilities in nonpolar solvent. Next, consider the gas dissolved in polar solvent. As I mentioned before, the regular solution equation can only be applied in nonpolar solvent, so the author made some empirical modifications on the regular solution equation.
Hi, my name is Henan Wang. It's my turn to introduce the testing part. The testing part is divided by two sections, nonpolar solvent and polar solvent. We choose the ethane as testing gas and ioctane as nonpolar solvent. First, we search the reference to find ethane's critical temperature and pressure, the solubility parameter Δ1, Δ2, and molar volume. Second, we calculate the reduced temperature, then use this value to obtain the value of solute viscosity divide critical pressure from figure 1 and calculate the solute viscosity. And finally, we use the regular solution equation to calculate the mole fraction and make comparison. The calculated result and observed data are shown on the table. The error is around 10%, which indicates that we are able to make a good prediction of ethane dissolved in other nonpolar solvent. In order to verify other gaseous solute, we still need more properties. For the polar solvent, we choose carbon dioxide as testing gas and acetone as polar solvent. We make calculation the value of activity coefficient by using the information from figure 5. Then use the similar way to calculate mole fraction. The results show that carbon dioxide cannot match this model and the real solubility is much greater than the calculated value, which indicates that some special influence factor acting on this gaseous solute.
Hi, Dr. Vargas and TAs. It's me again, Dacheng Gao. Finally, it's my turn to state some issues regarding this article. First, insufficient data in regression analysis. From figure 1, it is obvious to note that all the data are not dispersed very evenly. Most data concentrate on the TR range of 0.9 to 1.2 and 1.6 to 2.4. In addition, the authors did not provide any details in obtaining the fitting curves and its accuracy, so we doubt the applicability of figure 1 when used to get solubility in other range except the above ones. Second, last explanation about three-part plotting. The x-axis of figure 1 contains three parts. Vapor pressure data were used for the range from 0.7 to 0.8. Heavier gases solubility data were used for the range from 0.8 to 1.4. Lighter gases solubility data were used for the range from 0.8 to 1.4. However, the authors did not point out why they chose in this way. For example, we don't have much confidence in using figure 1 for estimating heavier gases at the range from the 0.8 to 1.4. Third, few explanation about some equations and terms. The first one is equation 11 in the article. However, the authors don't make it clear if this equation is semi-empirical or from theoretical derivations. More detailed information is needed. The second one is the equation 15 in this article. The authors stated that delta H2 for the step 2 is negative for the heavier gases and positive for the lighter gases. We can't read this information from figure 6 or figure 7, so more explanation is needed for the readers. The last one is typo. A typo is found at the beginning of the first paragraph in polar solvents part. It is shown below, and it is obvious that the last two words should be polar solvent. That's all. Thanks for your time and have a nice day.